Hey everyone, continuing from the previous video of where we talk about just simple differentiation. We talked about y equals to kx, where k is a real number, and y equals to k. But now you take let's look at a more generic algebraic function. Let's see how we're actually supposed to differentiate them. All right, start out simple. Let's say y equals to x squared. The derivative, well, works out this way. All right, first bring the power down to the front, so 2. Reduce the power by 1, so 2 minus 1 gives me back 1, x to the power of 1 is equal as x, and there we have it, the derivative of x squared. Applying the same logic, x to the power of 4, let's say 3x to the power of 4, dy dx, so bring the power to the front, so 4 times 3, reduce the power by 1, so 4 times 3, 4 minus 1 gives me back 3, and I'll get 12x cubed. This also works for negative numbers, any real negative numbers, right? So let's say I have 6x to the power of negative 4, right? This time around though, don't be tricked, okay? Similarly, bring down the power, minus 4 times 6 will give me minus 24. The power, minus 4 minus 1, is minus 5, not minus 3, so be careful. Obviously, we can always represent the negative powers as a fraction, and there we have it. So in general, we have this kind of a formula where let's say y equals to kx to the power of n, where n is any real number, could be negative numbers, could be positive numbers, could be pi, could be e, and we then have the derivative of n kx n minus 1. Okay, expanding that, right? We not just look at x only, right? But how about let's say where y equals to, let's say, 2x plus 3. Okay, square, whole thing square. Now, same thing here, all right? Not much of a difference. Bring down the power to the front, reduce the power by 1, keeping the bracket. So 2 minus 1 gives me back 1, so 2x plus 3 to the power of 1 is just 2x plus 3. However, though, now you have to differentiate inside as well. So to differentiate the expression or the function inside the bracket. So differentiating 2x plus 3 will give me back 2, so times another 2. This will result me in 2x plus 3. Maybe an even tougher example. So let's say 2x cubed plus 3x squared plus 6 to the power of 3. If I differentiate this function, alright, similarly, just follow the steps. Bring down the power to the front, reduce the power by 1, so 3 minus 2 will give me back 2. So this, plus 6 square. Differentiate inside now. So differentiate 2x cubed, following the rule, 6x squared, plus differentiate 3x squared as well, so 6x, plus 6 differentiated just gives back 0, so forget about it. I'll end up getting 18x x plus 1. I mean, I'm just factorizing as I go. 2x cubed plus 3x squared plus 6 squared. I mean, if you don't notice, I can factorize 6x from 6x squared plus 6x, and that will be my final answer. Therefore, we have this general formula for the power rule. So y equals to k, let's say fx is an algebraic function, or actually technically any other function, and dy dx would then give me n k f prime x differentiated inside, and therefore reduce the power by 1, and this would give us the general formula.